Hello dear students, good evening. In this video I am going to explain about what is long-term scheduler, what is short-term scheduler and what is medium-term scheduler. Okay, and what are the differences between these three types of schedulers. Okay, first before going to that topic we have to see what is a process, right? A process, we all know a process means a program under execution. When you are executing any program, that is called as a process. A program under execution is called as a process, right? Every process will go through different states. When any process is executing, it is going in the different states. It is changing its states, right? First, the process, whenever the process is being created, that is called as a new state. And whenever any process is waiting to be assigned to a processor. Processor means what? It is a CPU. Process is waiting to get the CPU to execute, right? That is ready state. Ready state means what? Process is waiting for CPU. If you allocate CPU, it will start executing. Next one is running state. What is the meaning of running state? The instructions are being executed. It is in the execution state, right? We are allocated the CPU and CPU is being executed this process. Next one is waiting state. What is the meaning of waiting state? Suppose this particular process which is executing by the CPU is waiting for some input. It is stopped executing and it is waiting for some input from the user. This is called as waiting state, right? The process is waiting for some event to occur, such as IO completion or any signal, to waiting for some signal or waiting for some IO. That is called as waiting state. Next one is what is terminated state. Terminated state means what? It has finished its execution. The process has finished its execution and it is terminated state. I hope you understand what are the different states of every process. Right now we will see with the help of the diagram. You can see here. This is here we have just created a process. This is called as here new state, right? And after creation it is coming into the ready state. That means it is waiting to for CPU. When you allocate CPU, it is going to running state, right? From the running state it may go to terminated state. Sometimes it is going to blocked. That means it is a waiting state. It is waiting for some IO or some signal, right? This is a blocked suspended. So sometimes this queue, this blocked queue is full. It will go to the blocked suspended queue, right? From here it will unblock. Thus when it is unblocked, it will go to ready suspended. From this ready suspended again it go to ready state, right? This is a detailed diagram of every process how it is executing. Now we will see what are the different schedulers. Right, first one is long-term scheduler. This long-term scheduler, it is also known as job scheduler. Right, what it is doing? This scheduler regulates the program and select process from the queue. It is the job of long-term scheduler is it is selecting the jobs from the job pool. It is one of the queue where all the processes are residing initially. This is a job pool. From this job pool, what is this long-term scheduler is selecting the processes and it is loading into the main memory, that is ready queue. It is selecting process from the queue, that is job pool, loads them into the main memory for execution. Right? First point is what? It is a job scheduler and it is selecting the processes from the job pool or queue and it is loading into the main memory. It is this ready queue is there in the main memory. Next one is it is regulating the degree of multi-programming. It is helping the multi-programming. Means what is a multi-programming ma? CPU. Keeping CPU busy always. CPU is always busy here. CPU is not idle, right? And one more important task that is done by the long-term scheduler is it is selecting the mix of jobs. From this job pool, this long-term scheduler should select the mix of jobs. Like some jobs are some processes. Konni process ki they need more CPU time, right? They need some process need more CPU time. Some processes needs more IO time, right? Ikkada long-term scheduler has to take care. It should not select all CPU bound processes. It should not select all IO bound processes. It should select mix of jobs. Why? Can you tell me why? If it is selecting all CPU bound jobs, what is the problem? Always CPU is busy, IO devices are idle. If the if the long-term scheduler is selecting only IO bound processes, the CPU will become always idle, right? That's why the long-term scheduler should select the mix of CPU bound and IO bound jobs. I hope you are clear with this. The long-term scheduler. Long-term scheduler is clear to you? Okay, next one is medium-term scheduler. What is this medium-term scheduler? From this diagram, see, here you can see, here there is a job pool. From this job pool, this long-term scheduler is selecting the jobs P1, P2, P3, P4, P5, like these jobs are there. It is selecting the jobs and it is keeping P1, it is IO bound. Suppose it is IO bound. Next, it is selecting P3, it is CPU bound. Next, P4, IO bound. Like this is the job of the long-term scheduler. Next one is short-term scheduler, medium-term scheduler. See, we will see first is short-term scheduler. What is this short-term scheduler? It is what is other name? It is having some other name that is called as CPU scheduler. CPU scheduler means the main goal of this scheduler is to boost the system performance according to set criteria. What it is doing? It is select from the group of processes that are ready to execute. Here, see, here this is ready queue. Here all the jobs are waiting to execute. P1, P2, P3, P4. Here processes are waiting. This is a main memory. Where is this ready queue is located? It is in main memory. Long-term scheduler already selected the processes and it kept the processes in the main memory, right? P3, P4. It is selected and kept here. Now, these process should get the CPU, right? To execute, these process should get the CPU. Who, who out of the waiting here, P1, P2, P3, P4 are waiting to get the CPU. Which process will get the CPU first? Which process will get the CPU first? Who will decide? Here, this decision will be taken by the short-term scheduler. షార్ట్ టర్మ్ షెడ్యూలర్ ఎలా సెలెక్ట్ చేస్తుంది? ఇట్ విల్ యూజ్ ద సిపియు షెడ్యూలింగ్ అల్గారిథమ్స్. సిపియు షెడ్యూలింగ్ అల్గారిథమ్స్ యూజ్ చేసుకుని ఏ ప్రాసెస్ విచ్ ప్రాసెస్ షుడ్ కమ్ ఫస్ట్, విచ్ ప్రాసెస్ షుడ్ ఎగ్జిక్యూట్ ఫస్ట్ విల్ బి డిసైడెడ్ బై షార్ట్ టర్మ్ షెడ్యూలర్, రైట్? I hope you understand what is the job of short term scheduler. Now I will show here. This helps to select from a group of processes that are ready to execute and allocate CPU to one of them. What we have to do here? One of the process should be allocated to the CPU. That is the short term scheduler job. Right, ma? Next one is medium term scheduler. Here medium term scheduler means mainly swapping. What is swapping? I will tell you here. Here see, suppose here process here this is main memory, this is CPU. CPU is executing process P1. After here P2, P3, P4, P5 is there. Now after some time process P1 is suspended. Why? Because it is required some IO input. It is requesting for some IO and this is suspended by the CPU. Now here process P1 is idle, right? It is not doing anything and it is located in main memory. It is occupying the main memory space. P1 is now currently it is suspended. Why? Because why it is suspended? దీనికి ఇప్పుడు ఇన్పుట్ అవుట్పుట్ అవసరం ఉంది. It is waiting for a signal or it is waiting for output. It is waiting for input. Now this is in a suspended state. Now what we have to do, some other process, maybe some P6 want to come into the ready queue. Here there is no space in the main memory. Main memory లో స్పేస్ ఉందా? ఇక్కడ స్పేస్ లేదు. మనం ఈ P1 అనే ప్రాసెస్, this P1 process is suspended. What we have to do? This P1 process should move into the disk space. This P1 process should move to the disk space. Disk అంటే ఏంటిమా? This is a temporary storage area. టెంపరరీలీ P1 ని మనం ఎక్కడ స్టోర్ చేయాలంటే మెయిన్ మెమరీలో నుంచి తీసుకొచ్చి ఇక్కడ డిస్క్ లో స్టోర్ చేస్తున్నాం. Why? Because to allocate some other process in the main memory. We want to allocate this space to some other process which is ready to be executed. This is called as swapping. Who is doing this job? This swapping job is done by whom? This is done by medium term scheduler. మీడియం టర్మ్ షెడ్యూలర్ ఏం చేస్తుందమ్మా? ఇక్కడ ఏదైనా ప్రాసెస్ మెయిన్ మెమరీలో ఐడియల్గా ఉంటే ఆ ఐడియల్గా ఉన్న ప్రాసెస్ని డిస్క్లోకి మూవ్ చేస్తుంది. దిస్ ఈజ్ కాల్డ్ as swap out and it is bringing the new process. Here we are bringing P6, that is called as swap out and swap in. This is swap in. This is done by medium term scheduler. This dispatcher see here, in order to remove the process from memory and make space for other processes. Just now I told we are removing some process and giving space to another process. This is called as this is done by medium term scheduler, right? See here the differences. Long term scheduler, it is also known as job scheduler, right? It is minimal time sharing system. It is used in the minimal time sharing system type of systems. Speed is less. This long term scheduler speed is less compared to short term scheduler. It is allows to select processes from the load of pool. It is selecting the process from the pool into the memory, right? Offers full control. Next, short term scheduler is also known as CPU scheduler. It is insignificant in the time sharing order. Speed is fastest compared to short term and medium term. It is very faster speed. It is selects processes that is ready state of the execution. Ready state లో ఉన్న వాటిని మాత్రమే సెలెక్ట్ చేస్తుంది, రైట్? మీడియం టర్మ్ షెడ్యూలర్ ఏంటిమా? ఇట్ ఈస్ స్వాపింగ్ షెడ్యూలర్. This scheduler is an element of time sharing systems. It offers medium speed, right? It helps you to send process back to memory, right? It is swapping and swap out of the process. This is about the long term scheduler, medium term scheduler and short term scheduler. I hope you understand this. Thank you for watching. Have a nice day.